In this video, we are talking about rational exponents. Now, rational is another word for fraction, so we're going to be dealing with exponents that have fractions. This is the main rule that we'll be using to do these problems. This rule shows us how to switch something from radical form to exponential form. You'll notice the power from your base goes in the top of your fraction, and the root from your base goes to the denominator of your fraction, and this whole fraction is the exponent on the x. And we're going to need to be able to take some things in this form and write them in this form. So this would be changing it from radical form to exponential. And there's going to be times where we need to go the other direction, change it from exponential into radical form. In example 1, it's asking us to change this from radical form to exponential form. It's currently in radical form because it has that root symbol, and we're going to switch it to exponential form. So the base is x, it's not going to change, and then we need to decide the fractional exponent. The power, the 5, goes in the numerator, and the root, the 4, goes in the denominator or on the bottom. So the fourth root of x to the 5th is the same as x to the 5/4 power. And that's really all they're asking us to do here. We don't have to go any further. They're just telling us to change it to exponential form, which we did, so we're done. In example 2, we're asked to simplify. Now I've got a power of 1/3. Now this power of 1/3 and also powers of 1/2 are pretty special, and we should be recognizing that that is going to be something neat. So let's first rewrite it in radical form. So the base is 24, x to the 5th, and then let's put the 1 and the 3 where they go. The 1 of the 1/3 is a power. So I need to put it inside of here as a power, but the power of 1 isn't going to change anything. Anything to the first power is itself, so it's not going to have any impact. Now this 3 in the denominator, he is the root, so he is going to be right here. He is the cubic root. So anytime you have the 1/3 power, it's the same as doing a cubic root. Just like the 1/2 power is the same as doing a square root. So what they're really doing is having us simplify this radical. So I'm going to come up with two things that multiply to 24, one of which is a perfect cube. So I think I need 8 times 3 because 8's on the perfect cube list. And since we're doing cubic root, I want my variable in groups of 3. So we need x to the cubed, or to the 3rd power. And we'll have 2 more x's hanging out over there. Do what we can, circle what we can't. The cubic root of 8 is a regular 2. The 3 would be too messy. The cubic root of x to the 3rd is x. And this is not a group of 3, so he's got to stay underneath. So outside of the radical is 2x, and underneath the cubic root would be 3x squared. And so this is the simplified version of that original question. Let's do one more. Simplifying this is a little tricky. The problem is this is a cubic root, and this is a square root. And if they're not like roots, they're really hard to put together. But you notice they do have the same bases, so we can work with this, but not in this form. It would be really challenging in this form. Anytime you have these yucky roots that you're being asked to combine, it is almost always going to be easier if you do it in exponential form. So the first thing I'm going to do is switch these guys into exponential form. So this first one would be a base of x, 5 is the power and 3 is the root. So powers up above and roots in the bottom. The next one has a base of x. His power is 7. What's his root? There's no number written there, but it's not a 1. It's a square root, so it's a 2. At this point, you got to tap into some old skills of how to deal with exponent rules. So there's an exponent rule that says when you're multiplying things with the same base, like this, you would actually add the exponents. So we are going to do that rule, but our exponents are a and b. They're 5 over 3 and 7 over 2. So we're going to come out to the side here and find what the sum of 5 over 3 and 7 over 2 is. Now, in order to add fractions, we have to have a common denominator, so we need to change these. I think the common denominator we're looking for is 6. So to get the 3 to turn into a 6 for the first one, we're going to be multiplying top and bottom by 2, so the numerator would be 10. Over here, to make this one work, we're going to have to multiply by 3, so its numerator would be 21. And when we add fractions, the bottom's not going to change, but the tops are coming together here. So that is the sum of these two fractions. So that is the a plus b. That is the new exponent. So back over here, the answer to this is x with an exponent of 31 over 6. Anytime you are asked to simplify radicals, where you've got a bunch of weird radicals going on that you've got to put together, you are almost always better off to switch it to exponents first and then use your exponent rules to find your answer.